Good day. This presentation is prepared by engineer Mary Jane. Let's begin our discussion on the topic called anti-differentiation or integration. On our previous activity, I let you answer the question on what is integral calculus, and your answers are correct. Just an overview of the history of integral calculus. This was formulated by Isaac Newton and Gottfried Leibniz in the late 17th century.
Integral calculus, also known as anti-differentiation, is connected with differentiation. Which is why we need to learn first on our first semester about differential calculus before proceeding to integral calculus. The integral or integration process is the reverse process of finding a derivative. For example, if we'll find the integral of 2x, which is x squared, we can also find the derivative of x squared, if we'll do the reverse process. This notation represents the integration process. The elongated s symbol is called the integration symbol. This is the Latin word for sum or total. This function is the integrand or the derivative. A derivative function is often indicated with dx or other variable. On the right side of the equation, we can see the integral of the function, specifically the indefinite integral. And lastly, the letter c is the arbitrary constant of the integral. This constant is necessary for an indefinite integral. Since the integration is the inverse of differentiation, we can get the integral if the given function is a derivative.
There are two types of integrals. First is the definite integral. This is denoted by a number that represents the area under the curve and has certain limits, the upper and the lower limit. Second is the indefinite integral. This has no limits or exact value. In the indefinite integral, we put an arbitrary constant since there is no particular value on the limit. Let's start by learning the indefinite integral and its theories. This is indicated by an integral sign which indicates summation. The indefinite integral is a family of functions. Shown on the example, it is read as the integral of x cubed dx equals 1/4 x to the 4th plus c. The c symbol represents the constant of integration or the arbitrary constant. We add c to the indefinite integral because there are infinitely many functions that have the same derivatives. If we will derive 1/4 x to the 4th plus 1, the derivative will be x cubed dx. If we will derive 1/4 x to the 4th plus 8, the derivative will still be x cubed dx. If we will derive 1/4 x to the 4th plus 2, the derivative will also be x cubed dx. There are many functions that will come up to the same derivative, so that is why we use the arbitrary constant to represent no specific constant value in the indefinite integral. Now, let's proceed to the theories of anti-differentiation using the indefinite integral. Theorem number 1. The integral of the derivative of x. This theorem states that the integral of dx is equal to x plus c. If we will derive x plus c, the answer will be dx, since they are inverse operations. Theorem number 2. This theorem states that in finding the integral of a constant times a function, we separate the constant value outside the integrand and then we first solve the integral of the function. And lastly, multiply it with the constant value. For example, solve for the integral of 8 dx. The constant value is 8, so looking on the theorem, we separate the constant. So it will be 8 integral of dx. If you notice, the remaining function is integral of dx. Looking back on theorem number 1, the integral of dx is equal to x plus c. Therefore, the answer will be 8x plus c. Now moving on to theorem number 3. The integral of the sum and difference of functions. The integral of the quantity f of x plus minus g of x dx is equal to the integral of f of x dx plus minus the integral of g of x dx. This theorem states that when we have sum or difference of integrals, we can solve by separating those functions, perform integration and add or subtract the integrals. We'll see on the example later. Now let's proceed to the fourth theorem. which is the integral of a power or the general power rule. This is the most commonly used theorem. The formula of this is, the integral of x to the n dx is equal to x raised to the power of n plus 1 divided by n plus 1 plus c. For example, integral of x to the fifth dx. Using the power rule. So x to the power of 5 plus 1 over 5 plus 1 plus c. Then this will be x to the sixth power divided by 5 plus 1, which is 6, plus c. Another example, the integral of the quantity z squared plus z dz. On this given function, you will notice that there is an addition. Therefore, we can separate this two functions using theorem number 3. So it will become the integral of z squared dx plus the integral of z dz. Now applying the power rule, z to the power of 2 plus 1 over 2 plus 1 plus the integral of z dz, which is z to the power of 1 plus 1 over 1 plus 1 plus c. Simplifying, we will get z cubed over 3 plus z squared over 2 plus c. Or we can also simplify this final answer to 1/3 z cubed plus 1/2 z squared plus c. So this is an example of integration where many theories can be applied. Lastly, we have the theorem 5. The integral of x to the negative 1. X to the negative 1 is also equivalent to 1 over x. Therefore, the function could be 1 over x, dx. Or it could be the integral of dx over x. The integral of these is equal to ln of x, plus c. If we will see the integral of 1 over x dx, integral of dx over x, or integral of x to the negative 1, the integral will be equal to ln of x plus c. Now let us proceed to few examples applying the theories discussed. Determine the indefinite integrals as specified below. The integral of 6 dx, applying the theorem number 2. We separate the constant value which is 6, then multiply it with the integral of the remaining function, dx. Since the integral of dx is equal to x plus c, the final answer will be 6x plus c. Next example, the integral of x to the 8 dx. Here, we can solve using the power rule. So this will be x to the 8 plus 1 over 8 plus 1 plus c. By simplifying, it will be x to the power of 9 over 9 plus c.
Next example, the integral of the quantity 3x plus 5, dx. We first separate two functions. This will become integral of 3x dx plus integral of 5 dx. Next, we separate the constant value as you can see. It will be 3 times the integral of x dx plus 5, integral of dx. So this will be 3 times the x to the power of 1 plus 1 over 1 plus 1. The power rule. Then plus 5 times the integral of dx, which is x plus c. By simplifying, we have 3x squared all over 2 plus 5x plus c. We can also simplify this to 3/2 x squared plus 5x plus c. On the next example, try to solve this, then send your answer on the comments section below. Let's see if you'll get it right. Also, try solving this one. Now let's solve this using theorem number 5. But first we can separate the constant value outside. So this will become 6 integral of dx over x. Then apply the theorem 5, the integral of dx over x is equal to ln of x plus c. So the final answer would be 6 ln of x plus c. So this ends our discussion. This is Engineer Mary Jane. I hope you learned something today. To confirm your attendance, please comment present on the comment section. Thank you and have a good day.